Anyway, I wanted to talk about a few different things. One of the things I focus on is technologies and trends within the industry. And as he mentioned, IABM really is about a trade association with about 500 different vendors within the industry. So we focus on vendor-to-vendor activity, as well as work with many end users and putting things together as far as that goes. So with that, there we go. One of the things, as I said, I work on this technology and trends roadmap, and how that works is we plot things on the technology adoption curve. And when we look at that, we can see that just on the top, bleeding edge, early adopter, right up to commodity. So a lot of people use this roadmap as even their starting points on keynote speeches. Product line managers use this as well to plot their own products. We found out that corporate board members are actually starting to use this to get a better idea of where the different technologies and where the products sit. In other words, if they're commodity, they can deal with the low margin. If they're bleeding edge, then they're dealing with high risk and where that fits. So it's risk versus gross margins as far as that goes. And it also assists marketing activities where people put products, particularly within adjacent markets and where these things go. So this year's update has a few major changes of the major technology and trends roadmap groupings that the roadmap group figured out best to portray on this. And we actually started this in December. In the UK, we had our IABM annual conference, and it was very, very clear that edge computing is of primary importance to customers, and we don't really want to be moving huge amounts of content in between clouds and then having it processed and then moving it back again. So one qualification was the certain burst of computing power that's recovered. So that fits well within a cloud infrastructure. However, what is really cloud now really came to the big discussion. There are so many forms of cloud. We've got on-prem, we've got off-prem, public, private. And we really don't really need to focus on the type of cloud. Our interests are more about infrastructure and cloud services, such as microservices, and where they fit in. So it's a thing that we've been talking about, and a lot of the vendors are on board now. So I think it's important that we just don't simply say, oh, it's in the cloud, or it's running in the cloud, or what's happening. I think it's starting to really clarify that, oh, it's running in a cloud service, because that service may be on-prem, for all we know. It just may be a virtualized device. When we look at production, we used to have remote production on here, but it's very clear that RFPs don't specify remote production anymore. It's just simply expected that if you're doing anything within the production environment, it may be local, it may be remote, it really doesn't matter, you know. And you'll have conductivity, obviously. It may be through the public internet, it may be 5G, et cetera. And we detail that area in transport, in networking. So again, you know, we just changed from remote production to the group simply named as production. So as we've been talking a lot about today with artificial intelligence and machine learning, it's definitely taking center stage, you know, and it already has. A lot of people are using it for reuse of archives, closed captioning, subtitling, sports visual recognition. I think those areas, some of them are pretty solid. They're constantly improving. We see deduplication efforts happening. But we decided best to start to focus on Gen AI/ML. And you notice I'm putting ML in there because I'm sort of in the camp, what is AI? And I like the way Renard said this at the SIMTE conference. I was giving him an interview, and he says, the problem with AI is the word intelligence. And I have to agree with him. That is an issue on that. And the other thing is understanding, as we talked about a lot, about the training models. And that really comes under the grouping of provenance. As well as content security. We found, we focused on security architectures. We moved away from security workflows. And I have to say, a lot of people in the industry, and I'll bet you there's a lot in the room here, that don't take security, strong enough, because it does affect our business. If it's over secure and we got too many VPNs in and we can't get on air and those types of things. But anyway, it is a matter of focusing on secure architecture and where that fits in that. Sustainability is another area. And last year we just had sustainability, but it turned out a lot of people are greenwashing. They're simply talking about, oh yeah, I can do this or I do that. So what we've decided to focus on is tangible sustainability. And one of the groups that I work on is actually called Greening of Streaming, and we've started to actually do hackathons where we're measuring power. We've set up different servers, and we now use little TP-Link boxes to measure power, and we're sending out to different TV sets test sequences so we can sync them up. And in our first hackathon, it was very clear that an HDR set in HDR mode takes 40% more power than if it's in non-HDR mode. And you look at the number of HDR contents out there, so that's using a lot of power. So where does that fit? So running each under the different areas that we work on is create, produce, manage, publish, and monetize. So with that, I want to bring up our group here. And as we did last night, we all talked about the white chairs, so we're using them today. And I'm going to start, I'm not going to introduce everybody personally, but I'm going to start with Mike down here. Mike, maybe you can just tell us a little bit about yourself and your company.
Hi there. I work for Weka.io. We are a storage provider. I am a solution architect. So my job is to work with our customers, to work with foundation model providers, to work with customers that are trying to modernize their AI/ML procedures and how they do work. So I live in Python every day, I work with Docker containers every day, and I present a lot of PowerPoint presentations. Weka is essentially a software-defined storage system, not unlike you've probably used in your careers. The difference before is that it's software-defined first. So you can put it on any kind of commodity Intel hardware. It runs in the cloud, and it runs in a data center. Thanks.
Good. You're clearly not an audio guy, so we're going to get somebody up here to fix your, or turn it on or something to that effect.
Check 1, 2.
All right. Well, people know Chris, but go ahead, Chris.
Yeah.
Everybody knows Ross. You were just on, so.
Yeah. So I mean, yeah. Just quickly. So yeah. And I didn't really introduce myself a whole lot in the last panel, but my bias is toward live production, being at Ross Video. So we're laser focused on that area, and I kind of alluded to it before. We have kind of a company-wide directive. If you're not looking at AI in your job right now, you're not doing your job. And so we're clearly going down that road, not only with products, but with every aspect of our work. And I too create a lot of PowerPoints and do a lot of this talking. So yeah, good to be here.
That's good. And Tom Burns is here. Tom is CTO, Media and Entertainment at Dell Technologies. And you can say that's all computer stuff, but your Technicolor days really brings you into this industry.
I started on the vendor side about 100 years ago with Silicon Graphics and spent 25 years in broadcast, visual effects in post-production, and now I'm back on the vendor side again. So it all comes full circle.
Yep, and the roadmap.
So the most interesting thing about being part of Stan's team that comments on the roadmap and decides whether we should organize things into different categories like Stan was mentioning. But all of us, we have our day job, and so we're laser focused on the technologies that we need to get whatever project done. But there's always some things that we read about or we talk to a friend about or things like that that are just little flags like, oh, that's interesting. I'll just make sure to look that up in my copious amounts of spare time. And so being able to talk to hundreds of people that all have the things that I'm kind of interested in but don't know very much about, and this is their day job, and so we can, you know, I can talk about storage and compute all day long, and other people can talk about whether it's networking, whether it's AI, whether it's workflow orchestration, you know, all kinds of things get brought together from a bunch of different viewpoints to create the roadmap every year.
Now, when I first came up with the roadmap, I sent it around to different people, and Renard Jenkins was one of the first people that was in the group. And after he saw it, he said, he was working at PBS at the time, he said, I made every one of my direct reports, print out a copy and put on their office wall. And it doesn't matter what project they're working on, they need to go through that roadmap as a checklist. And which is good, because as you say, Tom, we're all laser focused on our own little spot and where we fit on that. So let's just talk about some of the details of the roadmap here for a minute. Certainly, as I mentioned, remote productions continually to improve, and I think we really focus on what we call hybrid productions at this point in time. And of course, we've got 5G, you know, private 5G networks. I think the Coronation was the largest 5G private network that was put up, and that's under GPRS is what that's called, a sort of a private network. So it's being used for, you know, people just thought it was being used for backhauls, but it's been used for IFBs, intercoms, you know, everything as far as that goes. Certainly we see volumetric production, you know, growing very quickly. And I think one of the problems that people quickly realized with volumetric productions was, I was talking to the guy in Belgium from VRT at the SMPTE conference, and he said, I wish I knew about having a matched camera to an LED background. I didn't realize all the more, you're smiling, you've run into this? Yes, okay. Didn't realize these activities are happening there. So I think these things are important aspects as well. And as we talked about earlier, is customers are recognizing the value of moving their content into the cloud with services as far as that goes. So tying these two things together, Mike, can you just talk about this? Your company has a cloud service offering where you can build a production studio in 40 minutes.
Yes.
So just tell us a little bit about that, and is that in between clouds? How's it controlled? Those types of things.
WECA is a cloud-first offering, so we designed it specifically in AWS, ported it to the other clouds, Azure, OCI, and we're in a situation where we can very quickly use a technology called Terraform to be able to bring up the storage system and all the applications in the backdrop. Part of what I do on a daily basis is validate the applications that are actually running on that system. It can sit on top of Kubernetes and use what's referred to as a CSI driver. So being able to bring that infrastructure up on demand in the cloud in less than an hour is a hard target, especially when you're talking about regional productions that have data gravity issues. Being able to upload, get the content close to the compute so that it can be modified, managed, transformed, and turned into useful material is a critical piece. And you can't do that if you're not software defined.
So, you know, one other area is digital twins. And digital twins are kind of hard to understand, but I'll bet you if we walk around at other studios here, there's a lot of digital twin stuff happening as far as that goes, because it's important to actually start to replicate your studio for that matter. You know where the equipment is. Go ahead.
It's a critical piece of, it's a happy marriage really of robotics, IoT, Internet of Things, taking that sensor data and blending it as metadata with footage that's going to be leveraged for something. Now, typically digital twins are used in a manufacturing context. You have a manufacturing floor, you have many different machines that are creating a product or a series of products. This video surveillance is absolutely critical, being able to parse that and make actionable events that are logged and tied to the outcomes that's required from a manufacturing standpoint. That model fits right into the work that you folks do on a regular basis. having those tools inside of that ecosystem and have it close to the data so that it can be actioned without you waiting for the ingest of that data is the differentiator between you getting something done and you waiting around.
Right. And Chris, just tell us a little bit more about some of Ross Video's recent AI stuff. I know you have to be AI, but
Yes.
talk about the recent, particularly on live production.
Yeah, the one that I like to kind of joke at least a little bit about is in camera robotics. So we've been in the robotics business for many years, but we've now decided to bring AI into robotics. And my joke was, what could possibly go wrong? Have you seen the Terminator? Yeah. But all joking aside, I mean that's one thing that we've done with our robotics is one of our free roaming robots now has AI built into it. Not just initially we did facial tracking, and that was kind of cool to be able to track the talent as they go across the set. But now we actually do body tracking, so that if the talent turns around, you can't see the face, it'll still track them. Or if they walk behind somebody, you can still see them and that sort of thing. So that's one of the areas that we've dove into recently, and Bo alluded to earlier. I mean, there's stuff on the roadmaps of all kinds of products that we've got that we're not allowed to talk about yet. But come and see us at IBC or NAB next year, and we'll be able to go a little bit more into it. But there isn't an area, as far as we're concerned, that can't benefit from AI, and that's why and I think live production has been one of the last areas to really benefit from it. It's arguably one of the more difficult areas to tackle. But we're working on it.
Well, I think one of the cool things that I came across, I get to interview a lot of companies at shows and things for their little reels, but people are getting rid of teleprompters now because AI just puts the eyes up there. If you're glancing down at your notes, it doesn't matter. AI just puts your eyeballs back, and it's
But they don't
really
blink.
cool.
Those AI
Actually,
eyes.
they do blink
Oh, do
now.
they
Oh,
blink?
they do blink
Oh, I
now.
didn't know that.
Oh,
Okay.
they are so real you would have no idea.
Okay.
Because they've grabbed enough information, and the person can move around, and the eye moves with them. What a surprise how that works. But anyway, Tom, tell me, certainly people store content multiple ways, multiple times. It's just a nightmare with archives. So does AI for deduplication really work?
Yes and no. I think it's important to say, and others have said it before, but I want to make the distinction between machine learning, old AI, and Gen AI, which is causing so much of the buzz lately. Block-based deduplication is a machine learning technique, and it's been around forever, and it works very well on block data. Media data is more tricky because of the way that different file systems lay out the actual contents of the media asset on block boundaries or not on block boundaries. So block-based deduplication systems, of which there are many, they often fail with media clips. So starting to do machine learning based pattern recognition, or whatever you want to call it, deduping, now the machine learning allows the dedupe algorithm to stretch over several blocks and to be variable so that it can tell when the media file starts and ends, instead of just saying, oh, compute block A, compute block B, got a hash here, they match. Often if you're looking at clips, the individual blocks may not line up perfectly. So the old style machine learning techniques have had to be expanded to work for deduplication when you've got 37 copies of the same asset on your storage volume and you don't know it and you want something to chew through it. But that's an important distinction about machine learning versus Gen AI. And just while I'm on my soapbox.
On your soapbox, go ahead.
Oh God, just as I said that, I forgot what I was going to say.
Were you going to ask me about what the difference between traditional machine learning and Gen AI is?
Why don't I do that, Mike?
So from my point of view, we saw a big change in how we do things. We got access to Lego. And that's what Gen AI is. It's a foundation model that's put out by a provider. Thank you. It's a foundation model that's put out by a provider, and it's just dangerous enough that we can get some work done with it. And we can enrich it with our own information. We can translate features that are in images that we're interested in having in our cookbook, we can turn those into symbolic things called embeddings. So an embedding would be something that would be recognizable as a stop sign, something that would be recognizable as a muffin, and the differences between how those would be presented. That specific requirement of looking at how we deal with embeddings has changed and transformed how we bring things to market. Instead of having to do giant science projects for months at a time, very often we'll download a model from Hugging Face. If you have a MacBook, you can run a command using Brew, and you can install an LLM on your machine, and you can have it chat with your documents that are sitting on your machine. Better be careful which documents you choose. But this is the world that we live in, as opposed to being in a situation where we're checking with people that work with Python notebooks all the time and asking them how it's going. People like yourselves are cracking open their MacBooks, and they're actually learning how to be able to curate their own types of workflows on their laptops. Open source software, software that's been brought to market by companies like Stable Diffusion. We're just seeing the tip of the spear. It's going to grow exponentially.
Can I jump in just for one more second? I remembered what I was going to say, and it was actually Mike that mentioned data gravity, although other people have said about data gravity. And the idea is that media assets are just too big to move. So whatever it is, you know that you're going to move the AI, the compute, shall we say, you're going to move the AI to the data rather than the other way around. And Sumar mentioned all of the extract, transform, and load process that older business intelligence data warehouse, you know, remember that original kind of thing? 75% of the data scientists, that person's time was spent just massaging the data so that it fit neatly into the, you know, oh, it's in aisle 11, bay 3. And that's a lot of manual manipulation until you get all the data in the same warehouse, and then you run the analytics or the AI or whatever it is on it. And then we talked about edge, and this is the same thing. So much data is produced at the edge these days that you have to actually have a way of moving the AI to the edge, either by running it on a laptop, like what you were saying, or through container storage interface plugins where you can have the cloud, the compute someplace, and the data anyway. But data gravity and stuff moving to the edge, those are the big trends that we isolated as happening in the roadmap.
Right. So let's not talk about AI for a second. And we're talking about where we are with regards to storage, but people are moving in the cloud. Should people keep it on LTO, the expense? Talk about LTO. Is it still alive?
LTO is fantastically cheap, and once it gets going, it's actually pretty good throughput too. The problem is, you know, big broadcasters with big libraries, think about the metadata that you've got on that old LTO archive. Even if you have a really modern asset management system driving that archive, sometimes all you got is show title, air date, and runtime, sometimes, right? So there aren't enough interns in the known universe to sit and watch and listen to all of that archived material in order to extend the metadata, get it tagged with more modern tags. And so if you don't have a way of, you know, machine learning again, not so much Gen AI yet, but you have to have a way of watching and listening to every single asset in your library in order to increase its monetizability, if that's a word, and make it searchable so that you can find, when we were talking about, you know, finding the exact clip of the exact sports thing, that's a lot of processing in order to generate that metadata in order to be able to find it right there. And finding it right there in the middle of a live production is pretty cool. I was impressed with that demo. But that's the problem with LTO. It's cheap, but it's dead. There's no, you know, it's not interactive.
So we need an AI cart machine.
Well, anything that would, as it's reading that data, give you real-time tags that are legit and generate and not hallucinations, that would be a godsend to everybody in the industry trying to make data products out, you know, for resale out of the archives that you've spent 50 years building.
Well, certainly that moves us into infrastructure and where that fits. You know, compute nodes and physical virtual machines, they're all incorporating XDP, RDMA, you know, DPTK, anyway, on and on, kernel bypass, et cetera, et cetera. You know, we can go on and on and on and talk about that, but Chris, I want to talk to you just for a minute. What's happening? Initially, moving to cloud, people just did lift and shift. Are we still in that lift and shift mode?
I have to say, sadly, yes. You know, we all talked about when we started moving things to the cloud that lift and shift was a terrible thing, and it was going to be temporary, and it was going to go away like tomorrow, right? That hasn't happened, and I think people have become a little more pragmatic about lift and shift, and have said, you know, maybe it's not actually the worst thing in the world to lift and shift solutions, at least to get them up to the cloud. So I've sensed, at least, and I don't know if you guys are seeing the same thing, kind of a shift in attitude toward that. It's not, it doesn't have the bad vibes to it that it once did. But you know, obviously, it's better to have something that is architected for the cloud, that is microservices based, you know, that can take advantage of all the inherent advantages that you have of moving to the cloud. But should that be to, you know, the exclusion of lift and shift? I think people have come to the conclusion that not necessarily.
Well, I think during the COVID stuff, it was all lift and shift.
Of course. Yeah. I mean, that was the only way we kept
Yeah.
television working, right? Yeah.
But really, the other issue with lift and shift is not only you maybe don't have new features you can start to add in,
Yeah.
but sustainability.
Yeah.
It's like if it's not native, it's not efficient. Go ahead.
From our point of view, one of the values of our software was that we introduced a tiering function. And that meant that we could use object stores as our cheap tier, and we could still keep our metadata local to our NVMe tier. So you'd be able to stream your data from an object store on demand and pay a lower price point of storage, be able to potentially have that object store go quiet when it's not in use, or run multiple object stores against different projects, all tied to a central location, and pay at a lower cost or burn less carbon, hopefully. This is against local data centers. This is against all of the clouds. All of the clouds have the same agenda. They're also putting pressure on people like us to be able to support ARM processors so they can be more efficient with those instances in the cloud. They're also trying to take GPUs and put them as close as they can to those CPUs to make sure those GPUs can be used, and potentially retire operations faster and cheaper than CPUs can. So there's all kinds of innovations around sustainability from a cloud-first standpoint. But I think the reason that we're seeing that pivot back is because initially C-level executives were pushed that they were compensated on how fast they could get things up to the cloud. And then we found out that it wasn't free. It wasn't even free-ish. And then
Come on, it was free to put it in the cloud.
Well,
we
yeah,
had
it's
You
getting
couldn't
off the
use
cloud
it,
that's the
you
problem.
couldn't have a service running, but you could put it up there, right?
trying to be very gentle with AWS and everybody else. But my point is, once you get it up there, you have to figure out how you're going to live in a world where you've got data on-prem, you've got data in the cloud, and you've got data in different zones, not necessarily near the compute that you've got. So that reconciliation has caused a bit of a pendulum swing.
Yeah, certainly with cloud infrastructure and where that fits. So we talked a lot about Gen AI and where that fits. As I mentioned, there's a lot of applications that are pretty good. And I do like to see some things that are happening, and you mentioned them today as well, about insights into customer churn rates, but also understanding loyalty and how to turn those around, and actually how to improve churn rates, because that is one of the biggest problems our industry has. And I mean, we can blame that when we went to skinny bundles on cable and things like that. Everybody realized that, oh, I'll just pick up Disney for a month and watch everything and then forget it for,
Yep.
you know, in a while. So those things are very important. But let's just get into a little bit deeper in this. We're talking about earlier today about all the infrastructure and computing you needed for that. So Tom, tell me about what is AI inferencing, and can you have low precision chips doing that? Do you have to have high-end GPUs?
One of the things we heard today was about the amount of hardware required to train an LLM from scratch. And frankly, I don't believe that the media and entertainment shops the customers that I talk to, whether it's a studio or a little creative boutique or a broadcast, they're never going to train their own LLM from scratch. And so the amount of compute required to run an LLM is ginormous. Dell makes these 8-way GPU servers. Think about 8 $50,000 GPUs all in one box, like that. And then you got to have the fast storage to keep those GPUs fed so that you're not wasting all of that investment. But nobody can afford to mount that kind of a hardware deployment for just the answer of, what should I have for dinner tonight, or something like that. So the idea is, once you've trained this LLM, you have this thing called a vector database. And that's the thing that you send queries against, and it's called the inferencing stage, where it actually returns you the answer. But some of these vector databases are huge, and you need all kinds of fancy NVIDIA grid licenses because the vector database has to fit inside the GPUs. And there's special techniques for cutting it all up so that it can fit in 8 GPUs. Dell and other people have been working on the opposite problem, because if you have these vector databases that are super precise, yes, they're going to get you to the right sequence of word based on that precision. But what if there is a way to reduce the precision in the vector database? You're still going to get to the same word. In fact, if you start getting vaguer and vaguer responses, then you've turned the quantization knob too far to the left. And what you want to do is keep that quantization just to the point where it slims down the vector database so that you can run it on one GPU, and really one like laptop type GPU, not even a super game engine type GPU. But getting it by quantization, by reducing the precision of the vectors in the vector database, and all kinds of slimming down the math required to get useful results out of that vector database, you can make it run just on a little, toy laptop GPU and still get the same quality of answers. And that's the quantization is the parameter, whether you're doing it in software or in hardware, that you can slim down these gigundi vector databases in order to put something that's useful on a laptop.
I also want to talk about machine to machine, where that fits. And people forget about that. They say, well, what is this machine to machine buying and things like that? Do I need a purchasing department anymore? Can the machine just order from a machine? That's kind of new. And I'm going, that's not new at all. If you ever bought an HP printer years ago, it just automatically, whether you accepted the yes or no, it just automatically orders your ink for you.
Yeah.
So I mean, machine to machine has been around, but I think when we look at AI and where that's heading and machine learning, I think we're going to see a lot more activities in that. At our IABM session at NIB, I asked Maureen, she's a director of media operations at BBC, about AI news anchors. And she said, certainly BBC won't be doing AI news anchors. So I mean, except maybe there might be a place for the weather person, right? A weather channel where we'll see that. So I was looking at this a couple of weeks ago, what's going on with AI, and I came across this site here. And actually the way this works is it has a really quick demo of how to bring up a newscaster with that. And in the demo, they just simply pulled up some news item. Who knows if it was true or not? That's the big question.
Need C2PA for that.
Well, and they used ChatGPT to rewrite it so they wouldn't violate copyright, which is, again, another big question.
Yes.
If you just rewrite something, trust me, rewriting a thesis for your PhD is an issue. So anyway, and then they pick an intro video, the news thing flying around or whatever. They pick a sound, they pick the background, they pick the talent, who it is, what they look like, and then they pick the voice, all these things on a drop-down box. They pick up some other videos, but believe it or not, in the video here, you notice it actually has a credit. Whoa. What a change. Anyway, and then you they hit render, and it rendered up pretty quickly, and then she's playing. So it actually did pretty good, but the arms and the eyes don't really move around right or anything like that. And I think that's the thing that came out of today with the paintings and everything, there's no soul in it. You know, you're missing that. But like I say, rewriting the copy just doesn't assume that's there, and that's really where provenance comes down. And certainly, we talked about AI hallucinations earlier, even though Charles doesn't like to call that. But some analysts estimated in 2023 chatbots hallucinated as much as 27% of the time, with factual errors being 46%. Wow. So we're down to coin flippings there. One of the guys in our working group, he's actually in Norway at NRK, and he took an MIT course on AI, and he says Gen AI just always hallucinates. It's just correct occasionally. So I think that's a good way of looking at it where it fits. But anyway, Mike, let's just talk about large language models. We've done a lot about this, where that fits, but is that practical for archives really at this point?
So I want to clarify some things that Tom was talking about as a kind of a lead-in. There's really two different things that we do with large language models. One of them is we take our core data and we will do something called fine-tuning. And that basically is reintegrated into the large language model. And that means that it's a monolithic thing that we can't crack open and really do a lot of work with. The other aspect is using what's referred to as a RAG pipeline. A RAG pipeline is just a database that's got embeddings that I was talking about earlier, features that are interesting to us. They're embedded in a database, and the LLM can reach in and it can say, hey, do you know about this? Do you know about this? And the inside of the database is oriented with something called cosine similarity. Things are grouped. Anybody who's ever flown over some type of topological map has looked at something and they've been able to assume things based on the lines of a topographical map. That's what similarity really gives you. It groups features that are alike. So with an LLM, if an LLM is talking to what's referred to as a RAG pipeline and you've populated it with data,
Hang on, actually in the panel you guys never said what RAG was.
It's retrieval augmented generation.
Right.
So you can just think of it as a database that's got ground truth in it. When you can chat with an LLM that's integrated into a RAG pipeline, a regenerative augmented a RAG pipeline, it will cite the information that's in your database. This is just like talking to somebody you don't know. You don't immediately trust them. You will want to find out where they went to school. You want to find out if they know anybody common. Are they going to lie to you? They're less likely to lie to you if they're citing information that you can look up. So that citation element of the RAG pipeline can be used to generate new data for tuning, like fine-tuning LLMs, or you can have this integrated and you can actually see the scoring. So you can get a confidence level. There's also a feature inside of the LLMs that's referred to as temperature. If you turn the temperature down towards 0, it'll work very factual and it'll only reference embeddings. It will not improvise as much. If you turn it up so that it's starting to approach a 1, an integer 1, it's a floating point number, it will improvise like Robin Williams on a stage. So don't use the temperature,
Yeah, but that's how we ended up with multi-camera sitcoms. So.
Anyway, my point about the whole thing is the RAG pipeline architecture will help us tune in grounded truth, assuming that we've put the right embeddings in those databases and that those databases are performant from an infrastructure standpoint.
Quick question. To make a RAG pipeline, is it as compute intensive as training in general?
No.
Is it, but it's more compute than just inferencing, which is like runtime.
It's actually, there's no difference between, from a compute standpoint with a RAG pipeline, it's just a relational database that's doing lookups. So it's like any other database that would be close. It's not computationally intensive. Where it can get computationally intensive is if you're adding more data on a regular basis. If your data that's in that RAG pipeline has lineage. So you shoot one season and you have scripts that are in there, and that's ground truth. And then you shoot the next season, you're going to age out that previous session, and you're going to want emphasis on the new content. So it's a living, very much a living system that if you want your LLM to be able to speak the truth, you have to provide it with the truth for now, not just the truth from last week. So that's where the computationally intensive elements come from, ranking, deranking and re-ranking. But an LLM can run on a MacBook with a Mongo database or something called Milvis. It's an open source database. Or some of you may have heard of SQLite. SQLite is the basis for a vector database called Chroma that Facebook uses. So, compute can be relatively lightweight at the edge. Where it gets complicated is when you have a foundation model provider that's trying to update their model every month or every week or multiple times a week. That's where you start to see massive scale of compute at the core.
Right, so in Providence, I would normally talk about C2PA, but we had a great go on that last night. That's something that certainly IBM and a lot of the members are focusing on. One of the members from our roadmapper group is from Sony in the UK, and he was telling us on our meeting that they've now incorporated it in the cameras as well, so it has a stamp. So these things are well underway. When we talk about secure architectures and frameworks, certainly there's a lot of standards like Zero Trust. And, we see NMOS, IS-10, and OS2, elements within the RFP process. But Chris, security frameworks are still not broadly adopted. What's the deal here? We have it on the IT side, but, we just don't have it in media operations.
I think there's been a little bit of a cart before the horse syndrome in our business, that we had to move things to the internet so quickly over COVID that people did that, and if we had done it another way, we might have done security first before we did that move, but out of necessity, we didn't. But I think we're at the point now where we realize this is absolutely necessary, and it's core to, if you're going to develop something that is going to run remote, it's going to run over the web, it has to have the secure architecture baked into it from the start. And it's actually quite difficult to retrofit that back. So I know a lot of projects I've been involved with are like, let's reimagine how we would do this if we did it right. I know that's not where we are right now, but in order to do this right, how would we do it? And maybe you need to tear down a lot of stuff to make it secure at its heart. And to us, what we're seeing in a lot of the RFPs are Zero Trust, IS-10, OAuth2, seeing all of those being specified as required, and that's what pushes the vendors in that direction. Not that we really needed a push; we knew this was coming, but it's security to me is going to be one of the big focuses over the next year or two. I think you're going to hear more and more about it at the industry events.
I think AI helps as well, because it can certainly define. It can look at your network and go, just before the news, it's all hell in a handbag, and then after. But if you've got it beforehand, you can figure out some of those things. And one of the other areas of security that gets forgotten is CDN leaching. It is really, really bad, but it's brushed under the carpet at the moment, and we're trying to get that cleaned up. On the contribution and delivery side, we can certainly see, I talked a little bit more about that, but Chris, just for a quick go, we've got a new streaming group running in the SMPTE RIS OSA, so that in 30 seconds.
Oh man, yeah. So we've got a brand new effort in the RIS OSA group within SMPTE that's focused on solving a major problem across the whole industry, which is that when I'm providing streams to all the various streaming providers that are out there, and that landscape is changing daily, first of all, it's completely, I'm going to make up a word as well here, Tom, unautomatable today. It's a kind of thing, the dirty little secret is this is managed on spreadsheets, even by major media companies right now, of being able to stand up delivery to new streaming services, because there are so many variables right now, and there's a total lack of agreement on how to make this happen. So what we're working on, we think standardizing it is a bridge too far, so we're going to just try to set some best practices around that. And a big part of that is securing these streams as well, because that's the other dirty little secret, is these streams by and large are not secure at all. That any kid in the basement can get the stream from, I'm not going to name names, but we can imagine the big media companies down to the big streaming providers. It shocked me when I learned about the lack of security of that. So we're working on that as well.
Absolutely. You and I were on the calls. We were just like,
Yeah.
whoa.
Yeah.
We don't want to tell people really what happens. When you look on the chart here under delivery, it may be confusing because if you look at publish, which is play out, you can see it's bleeding edge all the way to commodity in different chunks. Why? Well, certainly play out, within a cloud service and those types of things and transmitters, everything like that. That's all mature and commodity. But what is this bleeding edge stuff and where's the early adopter? Well, ATSC3 fits in that. But also what fits in that is BPS, which is the broadcast positioning system. And when security people or whatever hackers screw up our GPS, that's going to be the savior, is all the ATSC3 transmitters sending out BPS signals in that. So one of the things I also want to ask Chris about quickly is just talk about the Katina project. I'll give you 15 seconds this
Oh
time.
my God. I'll get you next time, Stan. Yeah, so that's the other big initiative we're working on in the SIPTI RISOSA group is something called Katina, which is solving one of the big problems we've got with the control plane across devices in the cloud. And on-prem and hybrid. We've got a real mess right now with so many different protocols out there. And we can actually see this getting far, far worse. As we go more to the cloud, go more to microservices, there are going to be players we don't even know about right now getting into this, developing new protocols. So we're trying to, with Katina, solve that problem with a standardized approach to that works equally well and is secure from the very beginning, on-prem, in the cloud, in hybrid environments, whatever. So we think this is a big, big problem that we have as an industry and we need a solution, so hopefully this is it.
We've been focusing a lot on the security side, absolutely, as far as that goes. Under orchestration and scalability, of course, I've squeezed in QC, and I think QC is very important. It seems to be forgotten, and I'll put a little pitch in here. I'm on an EBU subcommittee for QC, and we're doing a webinar next week. Just check my LinkedIn, and you can find out the details on that. But again, we've got different QC cards, and you can tie that into IMF, or you don't have to. You don't need to understand that. But without QC, it's actually, we won't say it's money saving, we'll say it's time saving, because you have to respin things as far as that goes. So I won't get into the tangible, stability or sustainability. We kind of covered that sort of thing. And we've got a lot of emerging trends. When you go on the website, you can certainly have a good look at the different things we're running. I'd like to thank the panel here. Cheers. And here's the QR code, and we'll leave the QR code up for a minute. How's that sound? And we'll go from there. I don't know if we have any questions or time.